Good morning. We are the Group 5 from MT-202, and for today we will be reporting our research proposal entitled Quantitative Analysis of Academic Stress Among Pre-Med Students, a Comparison of STEM and Non-STEM Disciplines. First, here are all the members from MT-202 that comprises this group.
My name is Anbiansi Capuno, and I will be talking about the conceptual framework of this research.
I am Laksa Lucia Beatriz, and I will be reporting the background and significance of the study.
Hi, I'm Crystal Sadi, and I will be stating the research problems and hypotheses.
My name is Sebastian Nicolai Tralde, and I will be talking about data gathering and data analysis.
I'm Kim Alonso from MT-202, and I'll be discussing the data gathering procedure, data analysis, and ethical considerations of our study.
This presentation's agenda overview. In the introduction, we will be discussing the background and significance of the study, the statement of the problem and hypothesis, as well as the conceptual framework or paradigm of the study. For the method, we will be discussing the research design, participants' sampling procedure, the research instrument that we will use, the data gathering, data analysis, and the ethical considerations. So let's begin with the background of the study. We know that academic stress is a significant issue that affects the well-being and academic performance of university students. It becomes even more pronounced among students who are aiming for medical school. And these pre-med students are often under immense pressure to perform well, which can negatively impact their mental health and their motivation. So according to Pigart et al. 2025, pre-med students experience higher levels of stress compared to their non-pre-med counterparts. However, what's not fully understood is how the students actually perceive, interpret, and cope with the stress. According to Tickman and Olsen 2025, they emphasize that this lack of insight presents a critical gap in our understanding of student well-being in the pre-med pathway. And while it is generally believed that pre-med students are more stressed, there is still limited research comparing the stress levels between different types of pre-med students, particularly between those coming from the STEM and the non-STEM programs. According to Mohammed et al. 2024, it is highlighted that the degree and source of stress may vary, but empirical evidence remains insufficient. According to Ding et al. 2025, they identified the need for a quantitative comparison. So STEM students typically undergo intensive training in biology, chemistry, and physics, those subjects, along with hands-on laboratory work, and this gives them a solid foundation for the medical field. However, in contrast, the non-STEM students may come from diverse academic backgrounds, such as business, humanities, or sports, which can offer unique perspectives, but it may not provide the same level of preparation in core sciences that are needed for the pre-med track. So, understanding how academic stress varies between these two groups is important, not only for guiding future students in choosing their academic tracks, but also for developing better support systems that are tailored to their needs. So, to sum it up, pre-med students are widely known to face academic stress, and therefore, our study seeks to fill the gap by comparing the stress levels between the STEM and non-STEM pre-med students. So, for the significance of the study is significant because it addresses a clear research gap. By doing so, the findings can provide valuable insights into how students' prior academic preparation or chosen program influences their educational experiences as they pursue the pre-medical track. So, the results of the study will benefit the following groups. First, our findings will directly benefit pre-med students, both current and prospective. For the future students, this study can help guide their choice of academic track based on their strengths, their learning preferences, and ability to cope with stress. For those who are already on the pre-med path, it provides them awareness of the specific challenges tied to their program, which can help them develop better strategies to manage their academic stress. Second, educational institutions and faculty. So, universities and colleges offering pre-med programs may use our findings to improve academic support systems. This might include offering tutoring services or mentorship programs or stress management workshops. And in particular, the study could highlight the need for additional support for non-STEM students who may face difficulties with science-heavy coursework. And lastly, this study will contribute to the academic field and future researchers. By exploring an area with limited prior investigation, it adds to the body of knowledge on academic stress in higher education. So it can serve as a useful reference for future studies, whether to explore interventions or to expand the comparison to other programs and disciplines.
This study aims to explore the levels of academic stress among pre-medical students by comparing those in STEM fields with their peers in non-STEM disciplines. We focus on understanding whether students' academic programs significantly impact their level of stress or stress levels. To do this, the research seeks to answer a few following questions. First, is there a significant difference in academic stress between STEM and non-STEM pre-med students? We examine their average reported stress levels and analyze whether this difference is statistically meaningful. Second, we look at the major academic stressors each group faces, whether it's exams, deadlines, or academic competition, and whether these stressors are unique to each group or commonly shared. Third, we explore the impact of perceived academic workload, like how many hours the students spend on studying or assignments, and whether this correlates with higher stress levels in each group. Lastly, the study investigates the coping mechanism used by these students. We ask what strategies are most commonly in each group, and certain methods linked to lower stress levels. By addressing these questions, the study hopes to better understand how academic discipline shapes the stress experiences of future medical professionals.
I will be talking about the conceptual framework of this research is based on independent and dependent variable models. This model was applied to clearly illustrate the relationship between the variables of the study and specifically how the independent variable may influence the dependent variable. In this study, the independent variable is the academic discipline, which categorized into two groups, which is first is STEM and non-STEM. This variable serves as the basis of the classifying participants, allowing us to compare levels of academic stress between these groups. On the other hand, the dependent variable is the academic stress. This is the main outcome of the interest, as the researchers aim to measure and analyze the level of stress experienced by pre-med students in their academic environment. The paradigm of the study may be visualized as follows. On the left, we have the independent variable, academic discipline, STEM versus non-STEM. An arrowing point towards the right indicates the influence or effect of this variable. On the right side, we have the dependent variable academic stress, which represents the outcome being studied. In the summary, the conceptual framework demonstrates that academic discipline, whether STEM or non-STEM, may influence the level of academic stress experienced by pre-med students. This framework guides researchers in testing their hypothesis and analyzing the relationship between two variables.
Researchers obtained permission from the STEM's coordinator to conduct the study. Medical technology students were invited to participate and are informed about the study. Participants were selected on a specific criteria, enrolled in pre-med, STEM, or non-STEM, and are experiencing academic stress. Consent was then obtained and participants were reminded for their right to withdraw. Data was then collected via Google Forms for convenience. Respondents were assured of anonymity, confidentiality, and that their data would be later used for only academic purposes and later deleted. For data analysis, Data analysis involves organizing, examining, and interpreting quantitative data from STEM and non-STEM pre-med students to compare academic stress levels. Responses are first checked for completeness and accuracy, with incomplete data being addressed or excluded. Data is then coded and entered into a statistical software for analysis and using descriptive statistics to summarize participant demographics and stress levels. Inferential tests, such as independent t-tests or Mann-Whitney U-tests, will compare stress between groups with additional analyses, exploring factors influencing stress. Statistical assumptions will be checked to ensure validity, and results will be presented through tables, graphs, and narratives.
To begin with, we initiated the data gathering process by sending a formal letter of permission to the coordinator of the SNAMS department. Once we received the approval, we invited medical technology students from various sections and year levels to participate in the study. Participants were informed about the purpose of the research and were screened based on the following criteria. First is they must be enrolled in a pre-medical education program. Second, they must either come from the STEM or a non-STEM academic background. And third, and most importantly, is they must be experienced academic stress. Students who did not meet this criteria were not included in the study. Before collecting the data, we provided the participants with an overview of their research and obtained their informed consent. We also emphasized their right to decline or withdraw from the study at any time. Surveys were distributed through Google Forms, which serve as the most accessible and practical method given our online learning setup. After data collection, we reminded participants that their responses will remain confidential and be used solely for academic purposes. All collected data will be securely stored and deleted after the completion of the research. Moving on to data analysis, once all responses were collected, we reviewed them for completeness and accuracy. Incomplete or inconsistent entries were either excluded or addressed during the data cleaning process. The validated responses were then coded and entered into statistical software such as SPSS, Excel, or R. We first conducted descriptive statistical analysis to summarize the demographic profiles and overall stress levels of the participants. Next, we used inferential statistics to employ group differences and relationships. Depending on the data's distribution, either an independent samples, t-test, or a Mann-Whitney U-test was performed to compare academic stress between STEM and non-STEM students. Additional analysis, like correlational or regression, may also be used to identify other contributing factors to stress. Throughout the process, we made sure to check the assumption of each statistical test to ensure validity. The results will be presented using tables, graphs, and narrative interpretations aligned with our research questions. Lastly, regarding the ethical considerations, we followed strict ethical protocols to safeguard our participants. Informed consent was obtained from all the respondents and they were made fully aware of their rights, including the option to withdraw at any time without consequences. Anonymity was maintained throughout the study. No personal identifiers were collected unless absolutely necessary, and any sensitive data was handled in compliance with privacy laws and institutional guidelines. Participation was entirely voluntary with no pressure or academic incentives involved. Given the sensitive nature of the topic, academic stress, we ensured that all survey questions were respectful and non-intrusive. Participants were also informed that they could skip at any questions that made them uncomfortable. If any respondents experienced emotional distress, we were ready to provide access to support services, such as counseling or mental health hotlines. Finally, the study underwent review and approval by the appropriate academic authorities to ensure that all ethical standards were met and that the well-being of the participants was prioritized at every stage. And that concludes my part of the presentation. Thank you for listening.
And that will be the end of this presentation. And here are the references, and thank you so much.